In this lab, we will explore the conservation of momentum and kinetic energy in two types of collisions, completely inelastic and elastic. We will measure the velocity of each cart before and after each collision, and then check whether momentum and kinetic energy were conserved. To perform this experiment, we will attach reflecting vanes to two magnetic carts and measure their position over time using motion sensors. Before taking any data, check that the track is level. You can adjust the height of the track end in order to level the track. The ends of the cart are magnetic. We can change their orientation such that they either repel or stick together upon collision. For a completely inelastic collision, we want the cars to stick together. We align the carts such that opposite ends will touch when the carts collide. For an elastic collision, we do the opposite, aligning like poles so that when the carts touch, they repel. Set up the two motion sensors facing inwards towards the track. These will measure the distance between each cart and the motion sensor during the run. Let's zoom into the carts. We will graph the position of each car in Data Studio. First, we will take data for the inelastic collision. We can also look at how the position of the carts change for the elastic collision. Let's take a closer look at the data we collected for the inelastic collision. Initially, cart 1 is moving while cart 2 is stationary. The position of cart 1 increases linearly as it moves away from the motion sensor at a roughly constant velocity. The carts then collide and stick together. After the collision, the carts now move together. The magnitude of the velocity measured by the two motion sensors should be equal. In this setup, cart 2 has a negative velocity because it moves towards motion sensor 2, while cart 1 has a positive velocity because it moves away from motion sensor 1. We can find the velocity of each cart before and after the collision by performing linear fits on the position curves. The velocity will just be the slope of this fit. Be careful when selecting which points to fit for each measurement. The velocities of the carts are not constant due to friction. You want to find the velocities of each cart immediately before and after each collision, before any significant amount of energy is dissipated due to friction. Once you have measured all the velocities, fill out the table for each collision in your lab manual. Calculate the initial and final momentum and kinetic energy in each case. The total momentum is just the sum of the individual momenta. The same goes for the kinetic energy. In each case, are these quantities conserved? How do these two types of collisions differ? Do your results match your expectations?